All right, so here's our first example, our first problem to solve. And we're going to start by reversing PEMDAS, okay, on the left side. Ask yourself, is there anything I can simplify? And some kids from Algebra 1 might say, oh yeah, you can distribute that 5. It's a misnomer to think you can distribute because believe it or not, distributing is only allowed with a regular parentheses. So I know up to this point, being an Algebra 1 or geometry student, you might say, go ahead and put that 5 in there. It's actually not allowed because distributing is only permitted if you're distributing like quantities. And this 5 is not an absolute value quantity as this is. So we're going to work from the bottom of Gelmdas to reverse the operations we see. At the bottom of Gelmdas is addition and subtraction. So I look here. I don't look in the grouping symbol because that's the last thing I do, and I see this 4. So I'm going to add the 4 to both sides. That's your first step. And then once I do that, I'm going to simplify both sides. This one's easy. It cancels because it's the inverse. This one will make 10. And then over here, everything else will just drop down because we have not determined or evaluated any piece of that part of the equation. Okay, so once we have done that, what we're going to do is we have now completed the bottom step of reverse Gelmdas, addition and subtraction. So now we're going to do the next step, which is multiplication and division. And this thing that you want it to distribute, you actually undo it by dividing because the inverse operation of multiplication is to divide. So once I have done that, I cancel this out because it's the inverse operation, and I evaluate this so that it equals 2. And this is the new thing, and one thing you'll learn about math is it's pretty much always the same procedures, but there's always one new step, and that new step is going to occur in Algebra 2 at either the EL level, the Gelmdas part, or at the grouping symbol, and in this case it's the grouping symbol. So what the absolute value means is this quantity is equal to this, but the absolute value is saying that this quantity is equal to its positive value, okay? So it equals 2, but it also simultaneously is mathematically equivalent to having another equation where the quantity is equal to -2, because in the world of absolute value, you saw earlier on the number line I showed you, these two quantities are the same value. So what I'm going to do now is just reverse PEMDAS again. So I'm going to start back at the bottom, reverse Gelmdas. I'm going to reverse that by doing addition and subtraction first. Then I am going to drop down what doesn't change and evaluate this portion. And then continue to reverse Gelmdas. I'm now dividing. And so my first answer that I get is that x is equal to -1. The other answer that I'm going to have is to reverse Gelmdas over here. And you might ask yourself, well, that looks like exactly the same thing. And it is on the left side, but on the right side, I start getting different numbers. Here I have -6 now instead of -2. And then I drop down my 2x and I divide by 2. Again, it looks exactly the same on the left side with this inverse canceling. But here I get an answer of -3. So the new thing in Algebra 2 is also, like in Algebra 1, you may have been told by your teacher to review these answers just to make sure you get a good grade. But in Algebra 2, if you don't check the answer, you may think you're correct, but have an answer that actually doesn't work. So the way you check it is you simply take this number here and you plug it back in the problem and see if you in fact get 6. So you do that, and this is going to look like a pre-algebra problem when you see all this in here, is you're going to put this in a parentheses where the x is. So we're going to put that right there, and we're going to evaluate that using, in the old days we called it Pemdas, but now we're going to call it Gelmdas. We're just going to go through the order of operations and see if those order of operations will yield 6, which is what it wants here. So let's see if it does. So this will make 2. -2, and then I add -2 to 4, okay, so the inside quantity is the absolute value of 2, and then the absolute value of 2 is 2, so I get 10, so 10 minus 4 is in fact 6, so this answer is valid. Let's see what happens when we put -3 in there. Okay, so this one also has to be valid to include it in my list of answers. Okay. So once I do that, we're going to complete this quantity. This is negative 6 plus 4, so that becomes negative 2. And now you can see how that problem is actually going to come out to the same exact value, because the absolute value of negative 2 is the same as the absolute value of 2. So this is, again, 10 minus 4, which is equal to 6. So we see that both of these answers check out. Now, what that means is I can write the answer as x equals negative 1 and x equals negative 3. So one way to write the answer is to simply say x equals negative 1 and then put a comma, x equals negative 3. But in Algebra 2, we learn about something called set notation, and we will talk more about this as we progress. But it's really a great thing to learn that this symbol in Algebra 2, it's a curly bracket, means list. And you may have seen it in previous subjects when you were younger. If you were looking at a set of data, they always had this symbol. And in fact, if you're a computer science kind of kid, you will notice that computer science is written inside of this curly bracket as well, because it is a list of instructions for the computer to follow. So when I put this in here, I'm going to put it in order, ascending order, so smallest to biggest. And this is also telling an Algebra 2 student that these answers are correct. In fact, if I really think about that, this should have probably been put in that order as well. So moving forward, if you're going to write it this way, you're going to want to also put it in ascending order, which is critically important when we do inequalities in just a few moments. So that's a better way to do that. All right, let's take a look at another problem. And notice I've changed it just slightly. I put a variable on both sides. It doesn't change the process. Okay, so you ask yourself, can anything be simplified here or here? The answer is no. So you start on the left side and you start reversing Pemdas. The only thing I can do is get rid of the very bottom by adding that 4. And some students will say, okay, well, you now have produced, this just drops down. So some students will say, what's happened here is you have now produced a situation where it's almost like a loop. Like, what do I do over here? Because now you have 6x plus 3, should I move the 3 over? Remember, the purpose is not to solve for x. The purpose is to solve the absolute value. So it's actually been solved. We are now actually done with isolating the purpose of the problem, which is to isolate the absolute value symbol, because that's the purpose of solving in Algebra 2, is to solve for the chapter you're in, the topic. So eventually we're going to get to quadratics and we will solve for squares. But now I'm solving for the absolute value, and now I obey what the absolute value says. The absolute value says that this quantity in here, 2x plus 1, is equal to 6x plus 3, but it's also equal to the negative version of that. So what that looks like is we just write down 2x plus 3, okay, 2x plus 1, and we set it equal to the negative quantity of this. So it's a whole negative sign, which would make it negative 6x minus 3. And of course, if that 3 were negative, which it's not, it would become a positive, because it's, think of negative as opposite. So the opposite of this expression is negative 6x minus 3, but the opposite of 6x plus minus 3 would be to put an addition sign there. Now I reverse Pemdas again. Again, now I'm solving for x. So I like to put my variables on the left. It doesn't really matter, but it's very critical with inequalities. So what I'm going to do there is I'm going to solve that in this manner, where I am grouping my variables on the left side and my constants on the right side, and I'm going to be doing that using reverse Pemdas. Okay, so I canceled this out. I evaluated this column. I'm now still at the addition subtraction stage. As you can see, you can actually use a step more than once to complete that out. This now cancels, leaving me with negative 4x. And over here, I end up with 2. And then I finally will complete this equation by dividing by negative 4. I'm now at the division multiplication step, and then I reduce my fraction. So my first answer is negative 1/2. Okay, over here I will complete the same process. I'll subtract 1. I'll do it on both sides. Here it cancels, but over on the other side, it gives me a new number that I did not have on the left side. So over here, I end up with -4, and then I'm going to add 6x. Notice that's a different step here because I'm now grouping my variables together. Forgot my little x there, I'm putting it in now. And then that will change because over here we had the original 6, but over here we have the opposite, -6. So the operation even changed, which is a neat thing to see. So here we end up with 8x is equal to -4. And then we divide by 8x, and we see an interesting situation where when this reduces, we get the same thing. We get -1/2. So the question is, why would that happen? Evidently, the distance that this equation produces is equivalent to the distance that this produces. And so the question now is, have we produced a situation that actually provides an answer? So let's check. Let's see if it did. So the absolute value of 2 times -1/2, okay, plus 1 minus 4 is going to yield, plus 1 minus 4, there we go, is going to produce, this will make -1 plus 1, so that's 0. So this comes out to the absolute value of 0, minus 4 gives us -4. So the question now is, does this give us -4? So when I see if this is equivalent to 6 times -1/2, okay, and then I subtract 1, right, I get -3 minus 1 or -4. So they are equivalent. -1/2 produces the same thing in the left as it does the right. And that's what you're looking for. That's really your overall goal, is to make sure that you've produced nice equivalent statements so that it shows the balance. Remember, algebra is really about finding balance within numbers, and this does show that this is the answer. So if you were to write that in set, you would just simply have a set, and it would just include one answer. Okay, so let's take a look at a problem that actually has some issues. This was an issue to have the same answer twice, but I'm talking about issues of whether or not something is correct solving-wise. So take a look at this example. I have a little stop sign here to try to get you to think about it. There is nothing to add or subtract outside of the grouping symbol, but when I divide by -4, what happens here is you end up getting the absolute value of x plus 3 is equal to -2. And I want you to stop and I want you to think about what that's saying. That is saying the distance from 0 of this quantity is equal to -2. And if you think about that logically, that has no solution, right? There's no solution to this problem. And we'll work through it and show you that if you didn't see it originally, that you would still get no solution. But it's really helpful to just know that, especially if you're taking an assessment, you don't actually have to solve that problem. Like logically, this doesn't make sense. Okay, so an absolute value quantity can never equal 0 since the distance is always measured with a positive number. Okay, so let's see what happens if we continued this problem. We would get x plus 3 is equal to -2, which is, the absolute value of x plus 3 equals -2, which is a mathematical fallacy. That's impossible. But algebraically speaking, algebra will work, so you could set it equal to -2, and then the opposite of that, which would be x plus 3 is equal to +2, okay? And then you solve this by subtracting 3 on both sides, and when you subtract 3 on both sides, you get x is equal to -5. And then here, you would subtract 3, and you would get -1. So a lot of my students will say, Mr. King, look, I got 2 answers. Did you check them, right? You got to check them. So if you take -5 and plug it into here, you would get -4, right? Absolute value of -5 plus 3. And -5 plus 3 is -2. So this would be -4 times the absolute value of -2, right? And that will come out to -8. Why does it come out to -8? Because this will become positive when I absolute value it. Well, let's see what it's supposed to equal. If it's supposed to equal 8. So the beauty here is the algebra is telling you you've produced balance. but you produce the wrong kind of 8. So you have the balance, but it's negative. So that answer doesn't work. This answer has to be excluded. It is extraneous. Same thing happens with -1. If I put in -4 and then the absolute value of -1 plus 3, I get a similar situation. I end up getting -4 times the absolute value of 2, which is again -8, and for the same reason, it does not work. So there is no solution even when you solve it. You would have saved yourself some time by going here and realizing that the distance couldn't be negative, but it proves it to you right here. So how would we write that as a set? Believe it or not, you can write it as what's known as the empty set, which is a set within nothing inside, or you could actually write out empty set. Believe it or not, that is also allowed to write out empty set. So there's also one more way to say this. We could say no solution, we could put a set with nothing inside, we could have empty set, or we could even draw this symbol right here, which means empty set.